Hello, this video is going to take you through how to find the domain and range of either a linear or a quadratic relationship when it's involved in a word problem. So let's start with a linear relationship. In this example, Billy Bob wants to rent a canoe for a day trip. He gathers this information from Big Pine Outfitters. The base fee is $40 and the hourly rate is $10. So that means it's $40 just to rent the canoe, and then it's $10 for every hour you have the canoe. We're going to start with completing the table of values. So if you have not had the canoe out for any hours yet, it's going to cost you the $40 just to rent the canoe. If you have the canoe out for 2 hours, then it's 2 times $10 plus the $40 to rent the canoe. So that would be 2 times 10 plus the $40. So that would make a total of $60. If you had the canoe for 4 hours, then it's 4 times 10 plus 40. So that's 4 times 10 plus 40, which is 80. And you keep doing that work. If you had the canoe for 6 hours, it's 6 times 10 for the hourly fee, which is 60, plus $40 for the base fee. So that would be $100. If you had the canoe out for 8 hours, 8 times 10 is 80, plus the $40 base fee is $120. And lastly, if you had the canoe out for 10 hours, 10 times 10 is 100, plus the $40 for the base fee. That would make a total of 140 hours, or dollars. And we are going to skip this part. Now what we're going to do is draw a graph of the relationship. In the table of values, the first column always goes on the x-axis, and the second column always goes on the y-axis. So in the first column, it's time, which we can call t. We're going to call it t instead of x. And this is our time in hours. And the second column is cost, which we're going to call c. Oops. We're going to call that c. And this is the cost in dollars. Now to plot the points. For 0 hours, it was $40. For 2 hours, it was $60. For 4 hours, it was $80. For 6 hours, it was $100. For 8 hours, it was $120. And for 10 hours, it was $140. Now what we do is graph a line through those points. And what you have to decide is it possible for this to continue, or is it going to stop there? Is there anything that says that the highest you can go is 10 hours? It isn't. So what you assume is that this graph can continue, and you would put an arrow on the end to show that it would keep on going. Now, for the domain and range. Finding the domain and range is exactly the way you would have with graphs that were not word problems. So for the domain, you look how far to the left does the graph go, and it goes to here, which has a t-value, time of 0. So the minimum time is 0. And the maximum time, because it's going to keep on going, the arrow shows that it's going to keep on going. The maximum time technically is infinity because it doesn't say how long you can rent the canoe for. If it said the maximum amount of time you could rent the canoe was 10 hours, then you would stop at 10. But since it doesn't say, then we stop at infinity, or it goes to infinity. For the range, how far down does the graph go? So the graph goes down to this point, which was 40. And how high up does the graph go? Again, because there's an arrow, it goes up to infinity. So the graph goes down to 40 and it goes up to infinity. So again, if you were told that it stopped here, then the highest your domain would go would be 10. And if it stopped here, the highest your range would go is 140. But since it didn't give a maximum, then we assume that it can keep going with this arrow. Now a lot of this we're going to skip, but we'll do question 1 here with the quadratic relation. So in this quadratic relationship, Billy Bob is golfing. He's using his knowledge of mathematics and physics to get a hole in one. So examine the graph to the right. We're going to state the domain and range of this shot here. So the domain, as always, how far to the left does the graph go? So you can see the graph goes to 0. There's no arrows. This is exactly where the graph starts. So the graph starts at 0. So that's going to be your minimum value of x. Your maximum value of x is right here at 400. There's no arrow because once it hits the ground, it's not going to go down below the ground. So the maximum x value is 400. Now the minimum y value, in this case the height, the minimum y value would be on the ground, which is 0, and the maximum y value, which is the height, goes up to here, which is about 175. So the minimum y value, or the height, would be 0, and the maximum y value, which is the height, is 175. So it's really just getting the domain and range from the graph the way we would normally do it, even if it's not a word problem. All right, and we're going to skip these. And we'll move on to this last example. This last example is similar to the first example, but it's going to be quadratic instead of linear. So Billy Bob is practicing his golf on top of his building. Unfortunately, the ball goes over the side of the building and onto the ground below. This function here, this is the equation, and it gives the height in meters as a function of time, t seconds for his golf shot. So what I've done is I've given a bunch of values of the time, and what we're going to do is substitute each of these into this equation to find the height. So we're going to start at 0 seconds. So at 0 seconds, we're going to figure out what the height is by substituting 0 in for t. So the height at 0 seconds is -5 times 0 squared plus 10 times 0 plus 15, and that is equal to 15. Now, to find the height at 0.5 seconds, we're going to substitute 0.5 in for the time. So the height at 0.5 seconds is -5 times 0.5 squared plus 10 times 0.5 plus 15. And that is equal to 18.75. Now we're going to find the height when the time is equal to 1 second. So we're going to substitute 1 in for t. So the height at 1 second is -5 times 1 squared plus 10 times 1 plus 15, and that works out to 20. And you're going to keep doing this. So for each of these values of x, or t, for each of these values of t, you're going to substitute each of them into the equation for t. So it's just substitution. So if you substitute in 1.5 seconds, you get a height of 18.75. If you substitute a height of 2 seconds in, you get a height of 15. If you substitute a height of 2.5 in, you get a time of 2.5 seconds, you get a height of 8.75. If you substitute a time of 3 seconds, you get a height of 0. If you substitute a time of 3.5 seconds, you get a height of -11.25. So all this is just substitution. So take each of these values of t, substitute them in to the equation for t, and figure out what the height is equal to. Question B is asking, are all the values in the table reasonable for the context of this word problem? So the context of the word problem is t is time and h is height. So this point here is not reasonable because it's not reasonable to have a negative height. We're assuming because these balls are going down to the ground that the ball is not, or that the golf ball is not going to go 11.25 meters down below the ground level. Maybe if they were throwing it into a pool, it could go into negative values, but it's going onto the ground, so your height can't be negative. Similarly, time can't be negative. So in this case, we would say that are all of the values reasonable? No, because time and height must be positive. So because that last point is not positive, basically that is not reasonable. So we would not consider that part of this word problem. Now we're going to graph this. Time is going to go on the horizontal or the x-axis because it's the first in the table. Height is going to go on the vertical or the y-axis. And we're going to plot these points. So at 0 seconds, the height is 15. At 0.5 seconds, the height is 18.75. That's about here. At 1 second, the height is 20. At 1.5 seconds, the height is 18.25. And at 2 seconds, the height is 15. Oops, that would be there. At 2.5 seconds, the height is 8.75. And at 3 seconds, the height is 0. And we're going to stop there because we don't want our height to go below 0. So in order to get the domain and range, what you want to look at is how high the graph goes to get the maximum y. The minimum y, or the minimum height, is going to be 0. The maximum height we need for the range. The minimum x is going to be 0. We need the maximum x for the domain. So the maximum height is at 20. And how long does it take for the ball to hit the ground? That would be over here at 3 seconds. So the domain, the smallest, or the furthest to the left the graph goes is 0 seconds. And the furthest to the right the graph goes is 3 seconds. Because again, we're not going to count this value because that value of anything past 3 seconds would give you a negative height. For the range, the lowest this would go is 0 because we can't have a negative height, and the highest it goes is 20. So that is how you find the domain and range of linear and quadratic relations that are involved in word problems.